Desk lamps typically do not require grounding due to a safety design principle known as double insulation. Double insulation incorporates two independent layers of insulation to prevent electrical shock hazards. The first layer provides primary insulation around electrical conductors. The second layer, usually an insulating enclosure or a special coating, offers supplementary protection. This dual-layer approach significantly reduces the risk of electric shock in case the primary insulation fails. This is why double insulation is considered very safe and effective, so much that it can be used in place of grounding. The purpose of grounding is to provide a low impedance path for fault current to return to the source, thereby tripping a circuit breaker or fuse and energizing the circuit. Double insulation achieves a similar level of safety by preventing the fault current from reaching the user in the first place. Firstly, consider the basic principles of electrical safety. Electrical shock occurs when a person provides a path for current to flow from a voltage source to ground. Grounding provides an intentional path for fault current, but double insulation prevents the current from flowing through the user in the event of a fault. Secondly, consider the construction of a double-insulated desk lamp. The internal wiring has standard insulation, typically thermoplastic high-heat-resistant nylon, or THHN, or polyvinyl chloride, or PVC insulation. The lamp's external casing is made of a non-conductive material or coated with an insulating material, such as plastic. If a wire inside the lamp were to come loose and contact the metal part of the lamp, the outer casing prevents anyone touching the lamp from coming into contact with the energized metal part. Thirdly, consider the difference between grounding and double insulation. Grounding requires a connection to earth, usually through a 3-prong plug and a grounding wire that connects to the electrical panel's grounding bus. Double insulation does not require a ground connection, which is why desk lamps often have 2-prong plugs. Fourthly, consider the applications where double insulation is commonly used. It is widely used in power tools, small appliances, and other devices where grounding might be impractical or unreliable. For example, a power drill with a plastic housing is double insulated. The motor and wiring inside the drill are insulated, and the plastic housing provides a second layer of insulation. Fifthly, consider the benefits of double insulation. It eliminates the need for a grounding conductor, which simplifies wiring and reduces the risk of ground loops. It also provides protection in environments where grounding might be compromised or non-existent. Sixthly, consider the limitations of double insulation. It relies on the integrity of both insulation layers. If both layers fail, there is a risk of electrical shock. However, the probability of both layers failing simultaneously is very low, making double insulation a reliable safety measure. Seventhly, consider the testing and certification of double insulated products. These products undergo rigorous testing to ensure they meet safety standards. The tests include dielectric strength tests, where a high voltage is applied to the insulation to verify its ability to withstand electrical stress. They also include mechanical strength tests to ensure the enclosure can withstand physical impact. Eighthly, consider the role of underwriters' laboratories, or UL, and other certification agencies. UL is an independent organization that tests products for safety. UL-listed products have been tested and meet UL safety requirements. Double insulated products are marked with a symbol, typically a square inside square, to indicate that they meet the double insulation requirements. Ninthly, consider the National Electrical Code, or NEC, requirements for grounding and double insulation. The NEC provides guidelines for electrical installations to ensure safety. While the NEC requires grounding for many types of equipment, it also recognizes double insulation as an acceptable alternative in certain situations. Tenthly, consider the specific requirements for lighting fixtures. Section 410. 42 of the NEC covers the requirements for lighting fixtures. It specifies when grounding is required and when double insulation is permitted. For example, a metal lamp holder wired with a 2-wire cord is not required to be grounded if it is double insulated. Furthermore, the power rating of desk lamps is generally low. Most desk lamps use low wattage bulbs or light emitting diodes, or LEDs, which draw minimal current. The reduced current significantly minimizes the risk of electrical shock. Even if a fault occurs, the low current is unlikely to cause serious injury. The combination of double insulation and low power consumption makes desk lamps safe to use without grounding. These factors also contribute to the overall safety of desk lamps. These products also comply with safety standards set by regulatory bodies, ensuring they meet specific criteria for insulation resistance, dielectric strength, and mechanical integrity. These standards help manufacturers produce safe and reliable desk lamps that protect users from electrical hazards. Double insulation relies on 2 layers of protection instead of 1. The first layer is the standard insulation on the wires. The second layer is an additional layer of insulation, usually a plastic case. This second layer of insulation protects the user from electric shock if the first layer of insulation fails. Consider a scenario where the wire inside the desk lamp comes loose and touches the metal case. If the desk lamp were grounded, the fault current would flow through the grounding wire back to the electrical panel, tripping the circuit breaker and shutting off the power. However, desk lamps are not grounded. Instead, they rely on double insulation. If the wire touches the metal case, the second layer of insulation prevents the user from touching the metal case and getting shocked. The low power rating also helps to reduce the risk of electric shock. If a person touches the metal case of the desk lamp, the current flow will be small. The current flow will probably not be enough to cause serious injury. Double insulated appliances have a symbol on them, usually a square inside a square. This symbol indicates that the appliance has been tested and meets the requirements for double insulation. The UL tests and certifies double insulated products. The UL listing mark on a desk lamp indicates that the lamp has been tested and meets UL safety requirements. The NEC also addresses double insulation in section 250.114. This section allows double insulated appliances to be used without grounding. Therefore, double insulation is a safety feature that helps to protect users from electric shock.